protagonisti al mondo. Nel 2008 ho fatto uno speech dove parlavo del suo libro Free qua, IAB Forum, ha scritto Long Tail, Makers, cioè veramente è il top. Ve lo ricordate, editor in chief di Wired? Lui per me è uno dei numeri uno al mondo e secondo me c'è un solo modo per accoglierlo, sta guardando, no? Io lo accoglierei così, vede la camera? Ok, perché non se l'aspetta, questa non se l'aspetta, ve lo dico. E se vi date una mano, cerchiamo di dargli veramente un benvenuto. È arrivato ieri sera e parte appena finisce lo speech per essere qui con noi. È davvero un'occasione straordinaria. Chris Anderson!
I'm honored. Thank you. Good morning. Thank you for the opportunity to be back in Milan. My apologies for speaking English. Italy and Milano in particular have a really important place in my heart because the reason I'm here is because I was inspired and launched into my new career by the Arduino movement. And Massimo Banzi and his team just outside here changed my life. And so I feel like there's a little piece of Italian technology in me every day. What I'd like to talk about today is a revolution that has been started by technology, but is affecting the economy as a whole. This is the next wave of the digital revolution. And this is the moment when the digital innovation model applies to everything else. This is the moment when the revolution we began online, on screens, becomes real. When the technologies that were once in factories come to the desktop. This is a moment that was started in places about 10 years ago, like Arduino, 3D printing, crowdfunding, and cloud manufacturing, and is now taking off at light speed, and I think going to dictate the shape of the 21st century. The three things I want to talk about in the half an hour that we have today are these. I'm going to talk about the new technologies that are enabling this revolution. I want to talk about how the web's innovation models are applying outside of the web. And I want to talk about how that's changing the shape of the world's economies. It begins with this. It begins with the simple notion of an industrial revolution. Once textiles, fabric, manufacturing looked like this. It was the spinning movement. It was the ability of one person to make one thread. And then we created a machine that looked like this. And this allowed one person to make many threads. This simple device, the spinning jenny, was the beginning of an amplification of human potential. It created the cottage industry. It created a world where we could make more clothes than we needed. It created a world where we moved away from the farms, away from the land, and to what began as small factories and then became big factories. And then muscle power was replaced by water power, with the water frame. And then this created the modern factory. And this moment, going from one person makes one thread, to one person makes 5 threads, to one person makes 100 threads, to one person makes 1 million or 1 billion threads, didn't just change clothes. It actually changed the shape of our species. This is what happened to life expectancy in England and Wales, where this revolution started, over that period. How is it possible that factories could let people live longer? And the answer is that as we moved from the land to the cities, as we moved from the farms to the factories, we concentrated people around the means of production. And when we concentrated people, we created a need for the infrastructure of modernity, clean water, sewage systems, education systems, healthcare systems. The need to build society around factories created the need for a modern society. And that infrastructure is why we today live longer and our population is larger. The factory created the modern world. This is what an industrial revolution can do. This is how the population exploded once we created this first industrial revolution. And this is global history seen through the lens of life, population, and quality of life. And basically nothing in all of history, Rome, Egypt, Greece, the Renaissance, Christianity, nothing changed these key metrics of human success more than the factory. And what the factory did is it moved us from muscle power to brain power. The machines replaced our muscles, and we could elevate as a species to do what we do best, which is create and think. And that was the first industrial revolution. The second industrial revolution did the same thing, but with our brains. Now we replace brain power with machine power, in this case, computers. But it wasn't just the creation of the computer. It wasn't the mainframe. It was the democratization of the computer. It was the desktop. This was the key innovation of the last 50 years, was putting power in the hands of regular people. Of taking, if the first industrial revolution took people and moved them to the machines, the second industrial revolution built new machines and moved them back to the people. And this created a social revolution. And I wanted to just capture one moment here. This was the moment of 1985. It was the creation of the desktop laser printer, 1 year after the Macintosh. And it created the idea of desktop publishing. And what I love about the idea of desktop publishing is that it takes one word, publishing, which is a factory, a printing plant, and adds to it another word, desktop, which is personal, which is in your home, which is about you. And that idea of democratizing factory work, of taking industrial acts and making them individual, is what was so powerful about the PC era. And originally, we didn't do anything very extraordinary. We made newsletters and lost cat posters and church flyers, but we got better at it. We realized that we now had the tools of the publishing industry within our reach. And then we were ready when 10 years later, the web came. And the web allowed us not only to create, but to distribute. And today, publish is a button in your browser that anybody can press for free. And when you press that button, you have all the power of the biggest media companies of the 20th century, of the television companies, of the newspaper companies, the radio companies. You have the ability to reach billions of people with the press of a button in your browser for free. And that's the power of democratization. And that's what was so powerful about the web's innovation model, is that it let anybody innovate. But that was only in bits. It was only on screens. It was just digital. It was a social revolution, but it was constrained to the electronic world. Now we have the opportunity to take that revolution outside of the digital world, off the screen, and to the lives around us. We call this digital manufacturing. And like the mainframe, there's nothing new about it. Factories have been digital for decades. What's new is words like personal and desktop. What's new is democratization. So rather than a laser printer, we have a 3D printer. And a 3D printer is right where the laser printer was. It costs about $1,000. It's still a little bit hard to use. It's still somewhat limited. It's not a manufacturing technology. It's a prototyping technology. It's a good way to experiment with ideas, but it's not a replacement for a factory. We're waiting for the web. The laser printer waited 10 years for the web. We don't have to wait 10 years for the web equivalent in manufacturing, because today we already have the web. And the world's factories are now connected to the web, and we call this cloud manufacturing. And so today, you can, if you have an idea, you can prototype it on your desktop with a digital file using free CAD tools that my children can use. Minecraft, a game that many of your children are playing, is a CAD program, whether they know it or not. These are on your phone, these are on your tablets, these are free on the web. We now have the ability to take ideas and prototype them with a push of a button. And then if we like them, push another button, and I've given you an example of Alibaba, but there's many other cloud manufacturing services. With another button, we can then manufacture them. We can get robots in China to work for us with the push of a button, and they take credit cards. It's amazing. It feels like the web all over again. We call this broadly the maker movement. And the maker movement is just the web generation meets the real world. This is a picture from Maker Faire, and I know there's been Maker Fairs around the world, including here in Italy. But the maker movement is just the grassroots element of this. The commercial elements are things like crowdfunding, Kickstarter, Indiegogo, Gogo. They're the new hardware renaissance. It's the wearables, it's the Internet of Things, it's robotics, it's drones. All these industries that now look like digital, high-tech entrepreneurship, and yet have moved into things that used to be too hard, that used to be too hard for small companies, that's too hard for individuals. Today, I run America's largest drone company. 2 years ago, I was a magazine editor. Yet, how is it possible that you can go from magazine editor to aerospace industry? And the answer is, hardware has gotten easy. It's now possible to start hardware companies, aerospace companies, with 2 people and a laptop and the web. So I'll talk to you a little bit about how this is and how broadly this can expand. But it's global. This is not a Silicon Valley phenomenon. This started in Italy. It started in the UK. It started in parts of China. It started across the US. These are makerspaces around the world, but it's not just the makerspaces. It's the schools, it's the homes. It is my co-founder, who was a teenager in Tijuana, Mexico, when I met him on the internet, and created a factory because he could. This is a fully globalized phenomenon driven by the spread of the internet and the fact that ideas are as widely found as people. The barriers to entry have never been lower in manufacturing. You don't need a factory. You don't need funding. You don't need permission. You don't need a college degree. If you have access to the internet, you have access to the tools of the new industrial revolution. As I said, I owe a great debt of gratitude to Italy for 2 reasons. One is the Arduino 2007 was the key year when all of this started. 2007 was the year that the sensors became available to regular people with things like the Wii controller, Lego Mindstorms. It was the first year that Arduino took off. It was the beginnings of the maker movement and Maker Faire and Make Magazine. And it was the beginnings of the open source 3D printing movement, which also started here. The software to drive the open source 3D printers that we use today was created here, called Slicer. It's created here in Italy. And the Arduino movement, which is an open source computing platform, was created here. And so you may ask the question, why? Why were these 2 fundamental technologies of this new industrial revolution created here in Italy? And I think the answer is that they both have to do with design. That unlike the old technological era, which was about the silicon or the code, etc., we've now moved past that. The technology is now so widely spread, so accessible, that we can move to the next level, which is it easy to use? Is it beautiful? Does it have applications outside the technology industry? When you look at the Arduino team, they're essentially designers, not technologists. When you look at 3D printing, it's essentially taking digital design and making it real. And I think this is a moment when Italy's design foundations, when Italy's design expertise, when Italy's design reputation allows it to become a technological leader by making technology easier to use and more beautiful. And these were two examples that are creating the tools to allow regular people to do just that. My own history began in 2007, and I started with Lego, Mindstorms with my children. And this was my first exposure to making software work in the real world. This ability to write code very easily and measure the world, and manipulate the world, and create robots that children could use was amazing. I couldn't believe it. And so my children were bored by the robots, and they said, I want a better robot. And so I thought, well, maybe the robot could fly. And so we put the Lego in a plane, and the plane flew, and it became a Lego drone, which is now in the Lego Museum in Billund, Denmark. And that was amazing. I couldn't believe that my children and I could build a flying robot. And so I created a website to sort of really ask, what's going on? How is this possible? And people started answering my questions. And it turns out that other people were thinking the same question. What's in a smartphone that can be used in a helicopter? What can I do with these new sensors that are in our iPhone? What can I do with the cameras and the GPS and the radio? It's so good and so cheap. And these technologies, which used to be available only to the military, are now in our pockets. What can we do with them? So we created a website. People started contributing. They started innovating. They started creating technologies. And so the next generation came along and said, that's great, but I don't know how to code. I don't know how to solder. Can you just do it for me? And so we created a company. And this is what the company looked like. This is my children building our first robot. It was a flying blimp, a balloon. We packed them in pizza boxes, and I thought that was the end of it. But the problem is that people kept buying them, and so we had to make more, and I couldn't get the children to make any more blimps. So I found a guy on the internet, Jordi Munoz, who I later discovered was a 19-year-old high school graduate in Tijuana, Mexico. And he agreed to solder some boards together for me. And I thought that was the end of it. And then he kept sending me pictures. He says, I've got a new space. 2010. And I thought, that's great. He's got shelves. He's got people helping him. Amazing. I thought that was the end of it. And he said, I've got a new space. I've now created a factory. I bought machines from eBay. We learned how to use them by downloading instructions from Google. We have pick-and-place machines and stencil printers and reflow ovens and CNC machines. And I was like, oh my God, this guy's amazing. And then he sent me another picture. He said, we've opened a second factory in Tijuana, Mexico. This is the clean room. I thought, they have uniforms. Who knew? And then he says, and the factory's bigger. And this is what happens when teenagers in Mexico, using credit cards and the internet, build an aerospace company. And at this point, I quit my job as editor of Wired, and I took over as CEO, where we raised venture capital, and today we're a big company. But this is what happened in a small number of years. You going from toys and my children to a high-tech global aerospace company in a matter of about 3 years, using nothing more than credit cards. Now today we look like a traditional company. Today we're venture-backed. Today we have teams of professionals, factories in China. But we didn't start that way. We started like the Kickstarter generation. We started like entrepreneurs everywhere, which is basically on the kitchen table and in a garage, just doing it because we could. And that's what I mean by a new industrial revolution. We know that software companies can start that way, but now hardware companies can start that way too. This is the kind of stuff we make. We make drones, and this is how we've now thought about this. We used to think that the only way you could do hardware was in China. We used to think that the tides of globalization were all going east. It was about cheap labor. And now we realize that we have the ability to do things here and there. You can prototype on your desktop. And then you can send things to China to make 100 or 1,000 with cloud manufacturing. And then if it succeeds, you can build a local factory using the same robots, the same machines that the Chinese use. Digital manufacturing has become global. That as things become more automated, they become the playing field becomes flat. Everybody buys robots for the same price. You can buy a pick-and-place machine or a CNC machine here in Italy at the exact same price as they do in China. And because it's a robot, the labor costs don't matter. And so once you get to, you can do 10,000, maybe 100,000 locally. That's a great way to explore the market. Then if it goes really mass, maybe you send it back to China to take advantage of the supply chains there. But this ability to kind of move back and forth between close to market, close to your innovation hub, or far away where manufacturing is more concentrated, this ability to move things around is what's so great about digital manufacturing. It allows us to manufacture where it makes most sense. Sometimes it's mass, sometimes it's micro. Sometimes it's just in time, local. Sometimes it's batch process for classic retail distribution. This was not possible before. It used to be a one-way street. It was all to China. And now it's a back and forth. This is a factory right next to my office in Berkeley, California. This is a furniture factory. And what I love about this picture is that it's a glimpse of the 21st century. This is what a furniture factory looks like. It's one robot, the yellow robot here, the Fanuc arm, loading another robot, the CNC machine, behind it. And at the beginning of the day, they stack these aluminum blocks. And the robot just takes one aluminum block, puts it in the other robot, it's turned into furniture, and then takes it out and stacks it in another stack. And the only human jobs in the whole factory are this guy in the background, Harold. He programs the robots. He's essentially an engineer. And then there's a couple guys who empty out the trash, the aluminum filings that go into the recycling bin. And this is sort of a metaphor for the 21st century manufacturing world. There's only two human jobs left in the factory. You either program robots or you take out the trash. And so, as we train a generation for the 21st century, you have to ask, which do you want to be? Do you want to program robots or do you want to take out the trash? Now that sounds like a bad choice, right? Programming robots sounds complicated and taking out the trash sounds like no fun. But thanks to the new industrial revolution, programming robots looks less and less like a technology job and more like a design job. My children, and perhaps your children, are growing up in a world where these tools, 3D printers, CNC machines, CAD, are in the classroom, where they are learning, where in the past they learned how to do PowerPoint or spreadsheets, they're soon going to be learning how to do digital design in class. And it's going to be as easy as playing Minecraft. And those skills, the ability to turn ideas into a digital concept on a screen and then press a button and have robots do the work, these skills are going to be as easy for them as word processing was for us. And so tomorrow, programming robots is going to look like playing Minecraft. And that's why this is such an encouraging picture of the future. Let the robots do the boring work. Let us do the creative design work. And the tools of the new industrial revolution are making that easier. So I wanted to end on one note before we take questions. These two men reflect the 20th century and the 21st. On the left, Ronald Coase, who created the concept of the 20th century firm. It was built around minimizing transaction costs. Why do companies exist? To make it easier to get things done. If people have assigned roles, jobs, responsibilities, you know who does what. She does accounts receivable, he does accounts payable, and everybody works in one office, under one roof, with clear titles, to get things done. Bill Joy, on the right, one of the co-founders of Sun, challenged this. And what he said was, whoever you are, wherever you work, most of the smartest people in the world work for somebody else. Now, this is true, but what are you going to do about it? And Bill Joy didn't have an answer. But today, we have an answer. Open innovation is the solution to Joy's paradox. We know the smartest people in the world for any given job are not here in this room, are not working for our companies, are not even in this country, but we don't know where they are. How do we find them? Maybe they're Chinese, maybe they're Indian, maybe they're African, maybe they're Brazilian. We don't know. And in the old model, we couldn't find them. They didn't go to the right school, they don't speak the right language, they don't already have the right work history. Maybe they're 14, maybe they're 75, maybe they've never been to college at all. We don't know in the old model because we don't know how to find those people. In the new model, in the web's innovation model, we don't have to find them. They find us. We create platforms for innovation. We create communities, and smart people find communities. If you give people a way to contribute, smart people will find a way. This is what we did with DIY drones. This is what open innovation around the world is starting to do. This is what the open source software movement did. This is what platforms like the App Store for Apple or the Android App Store do. This is increasingly the way all successful companies are working. They're creating ecosystems, opportunities for innovation to come from outside the company itself. What we've learned by building an aerospace company along these principles is that you can't beat open platforms for innovation. In a new industry where you don't know where the applications are, the only way to find out is to open it up and let the users tell you. Apple created the Macintosh, but we figured out what it was for. Scientists created the internet and the web, but we, the users, figured out what it's for. Apple created the iPhone, but all the thousands of companies that created apps figured out what it was for. And that's what open innovation looks like. In our company, it's really simple. We just sort of say, here's the project. Here's some jobs that need to be done. And then we say thank you. When people do a job, we just give them something like a t-shirt and say, we recognize your contribution, thank you. And they love that. If they go further, we give them hardware discounts. This is not why they're doing it. They're doing it because they can. They're doing it because we helped them get a job done. They're doing it because it's fun. They're doing it because it's their passion. All of these recognitions are just our way to acknowledge their work. But as they get further into it, it becomes an obsession. They turn it into a job before we ask them to. And all we do is just recognize their contributions. Eventually, after they've done all of this, we hire them. Almost all of our employees came out of our community. Almost all of our employees were working for us before we hired them. They were working for us as volunteers. They were working for us at night. They were working for us because of their passion and enthusiasm for the space. And only after that do we hire them. And they turn out to be the best employees because they've already proven their ability to do their job. There's no risk associated. By the time we've hired them, they've been working for us for years and will earn the respect of the community and their colleagues. It's the easiest hiring in the world, and it happens automatically because we created the architecture of participation. Platforms are magnets for talent. If you create an opportunity for people to innovate, they will. If you create an opportunity to recognize and highlight innovation, the best stuff will rise to the top. This is the innovation model of the web, and this is increasing the innovation model of all companies everywhere. So I just wanted to end with this note that this is what it looks like to me. As we look back from the origins of the Industrial Revolution to the new Industrial Revolution, you can see this change. Back in the old days, it was company versus company. They owned the means of production. Only those who owned factories could produce. Then, in the 20th century, factories became more widespread. Everybody could have access, any company could have access to a factory. But the question, it then became product versus product. Less about the means of production and more about what you're producing. But in the 21st century, it's not just a product. Only the platforms, only products that are also platforms will win. And so we're seeing Android versus iOS. We're seeing, Facebook versus Twitter. These are examples of platforms. And as we move into the Internet of Things and wearables, smart homes and all that, every one of those new markets will be won by platforms, not products. Behind the platform may be a company. The platform may be shipped in the form of a product, like an iPhone, but if it's not a platform, it won't win. So that is the shape of the new Industrial Revolution. It looks like the web, but it's much, much bigger. Thank you very much.
Yesterday, I say that I did an interview with Jeff Bezos a few years ago, and it was the only time that I had to stop the interview and say, "Sorry, Jeff, I need to write down what you say," because I couldn't lose that. So I was writing down a few notes. Every time you speak, it is very, very inspiring. Really great. A couple of questions. Do you have to catch a flight, or we'll try to be super quick?